in previous example, we used the present worth method to find the rate of return. This time, we're going to use the annual cost method. So to explain here, I'm going to start with example 7.2. In this example, there's an investor. He or she is going to spend $50,000 at the beginning for the first cost, maybe buy a small piece of property. And the annual operating cost for this investment is going to be $2,000 per year. And the income is going to be $3,000 per year. At the end of 10 years, the property is going to be sold for $70,000. We want to know what rate of return this investor is going to get from this investment. So again, like previous example, we're going to draw the cash flow diagram so that way we can see how we can find the rate of return here. First, the first cost, which is $50,000. That's initial cost at time 0. Your annual operating cost, so I'm going to skip years, that's continue to year 10. So this is just going to continue every year. And the size of the annual operating cost is going to be $2,000 per year, uniformly paid. And then you have the income, also uniform, and go from year 1 through 10. And the size of those payments are $3,000. Now the property is going to sell at the end of 10 years for $70,000. So that's $70,000. Now I want to know what rate of return we can get from this investment. So this time, rather than using the present worth method, we're going to use the annual cost method. So basically, we're going to say EUAC for revenue equal the EUAC for the cost, or the EUAC for revenue minus the EUAC for cost is going to be equal to 0. By the way, one thing I want to mention, in your textbook, they use rather than EUAC, they call it an AW. It's the same thing. They use annual worth value. So this is a better term to use. I call it equivalent uniform annual cost. Now, let's do it for this example. In this example, rather than using present worth method, we're going to use annual cost. So we're going to start with the income and our annual operating cost. Because these are at the same time, I'm going to subtract. So your net income is going to be $1,000. So the difference between $3,000 and $2,000. Now, since this is uniform, I'm not going to multiply by anything. I'm going to keep it uniform. So that's for annual operating cost and the income. The next thing, we have the selling price, which is $70,000. That's not uniform. That's at the end of 10 years. So we're going to make it uniform. The future value is given. You're trying to find the uniform. We're going to multiply it by this on A given F. I star, which is unknown, and 10 period. So that's going to be the equivalent uniform annual cost for revenue. Now we're going to subtract from for the first cost. 50,000 is not uniform. We're going to make it uniform by multiplying by A given P, I star, and 10 period. And we're going to set equals 0. Because, again, this is the EUAC for cost, your first cost. So this is my rate of return equation. I have to solve this equation. Again, like previous example, this is hard equation to solve. So the only way to do is just, if you don't have access to software, you have to use trial and error. So you have to give one I, which this one make it positive, another I, which is going to give you a negative value, and then interpolate. So I have done some trial before, and I'm going to start with I equal 5%. So if I do 5%, so it's going to be 1,000 plus 70,000. I'm going to substitute for I, it's 5%. A given F, 5% and 10 period, minus 50,000. A given P, 5% and 10 period. If you get those factors, A given F, A given P from the table, then you should get positive and $90.02. So this is my first guess. Obviously, that 5% didn't satisfy this equation, didn't go to 0. Now we're going to start with next I. Hopefully the next one is going to give you a negative number. So with I 6%, we're going to substitute in the same equation. We call this one rate of return equation. So 10,000 plus 70,000, A given F, 6% and 10 period, minus 50,000 times A given P, 6% and 10 period. If you find those factors, A given F, A given P from the table, this time you're going to get negative $480.26. A continuation of example 7.2. We try two different interest rates and we find the ISYE for revenue and the cost. And we find for I 5%, the difference between the ISYE for revenue minus the ISYE for cost, it was a positive $90.02. For I 6%, it was a negative $480.26. We are trying to find an I, which I call this an I star, which is your rate of return. ROR stands for rate of return, that make this equation equal to 0. So we're going to do a simple linear interpolation. And as usual, we're going to call this an, again, I'm going to do one more time in future. I'm just going to say we interpolate. So this is A, and this is the difference between these two numbers, B, and this is C, and that's D. So the ratio of A over B should be equal C over D. So C is going to be equal A over B times D. Now A is the difference between $90.02 minus 0, and B is the difference between the same number and minus, make sure you put the negative sign, minus 480.26. So that's the B value times the D here. The D is the difference between 5% and 6%. 6 and 5%. And if you calculate, the C value is going to be equal to 0.16%. Now, since this I is increasing, we're going to add to 5%. So it means my rate of return, ROR, which is I star, is going to be equal to 5% plus 0.16, which is a 5.16%. So that's the rate of return for this investment.